Now, the main advantage of doing binary I/O is it allows you to store things in very standard formats that can be read across different platforms, different machines, different hardware, and so on and so forth. In other words, it can make your data very portable. So data that you write in binary form can then be read by programs written in other languages, as well as systems that use other operating systems and different kinds of hardware and so on. The data input stream class effectively filters data from what would be a raw input stream into appropriate primitive type values or strings. In other words, it collects together the appropriate number of bytes and interprets them in the correct way, in the correct order, to deliver those primitives to you. The data output stream class does the opposite conversion. That is, it takes primitive values and puts them as streams of bytes in their rawest form. Both the input stream, data input stream and data output stream can be viewed as working in what's known as a pipeline. This is captured in the next slide in a diagram. So here we have the pipelines that are used by data input stream and data output stream. In the top diagram, working our way from right to left, we start with an external file, which is basically now a raw collection of bytes. It's treated as a stream of raw bytes, and then the data input stream filters those bytes by imposing structure on them, collecting an appropriate number of bytes together in an appropriate order, and then doing an appropriate interpretation on them to finally deliver to you either an int or a double or a string or whatever you're expecting to see there. Again, your expectation is important, because if you're expecting a double and you read a double and something else was actually written out to the file, you have no way of telling that, because all that happens when you ask for a double is it takes the next 8 bytes, interprets them as a double whether or not they were supposed to be, and delivers that result to you. So obviously it's important that you read things in the same order that you wrote them out, and if you don't know what that order is, then there's no way you can interpret the file. Having a look at the bottom diagram, the opposite conversion is happening here. We begin with some primitive, double, integer, string, something, and the data output stream object then converts this into just a stream of bytes, which ultimately goes out to the file. As I suggested on the previous slide, the order and format's important. You have to know what you've written out and in which order you've written it out, because you have to read it in the same way or you're going to misinterpret it. You'll notice in the IDE demo, in one of the demos just a moment ago, we purposely did something that's contrary to this. That is, we wrote data out in a certain order, certain things in certain orders, and then we read them in the same way, but then we reopened the file and treated it as a raw file of bytes and read one byte at a time, displaying its value. We're allowed to do that, certainly, and it was done as a matter of being an instructive way to show you what was there in terms of the bytes that were in the file. But it does go against what you read here, because in general what's going to happen is if you write out a double, you should be reading in a double. If you've written out a UTF string, you should be reading in a UTF string, and so on and so forth. So that order and format is going to be important for the use of binary files to make sense. In that demo, when I actually was reading that file as just a bunch of bytes, you'll notice I used the input.available method that you see at the bottom of this slide to see if it was more bytes to be read. So as long as input.available returns a result that's greater than 0, then you do have more bytes to read. As soon as it hits 0, that means there are no bytes left in the file, and therefore you've reached the end of the file.